You can put any number in there whatsoever and it will work. No matter what you put in, it will work. That's why it's called infinite solutions. If you're just looking at it from a calculation standpoint, if you wipe out the variables completely and you end up with two numbers that equal each other, like a number equals a number, then that's an infinite solutions problem. If it was 4 equals 4, or 2 equals 2, or 8.53 equals 8.53. Yep?
Does that mean x equals x counts? Yes.
Yes. Or you could even realize it right here, where you have the exact same equation on the left and the right. Example 4, I bet you know what I'm doing next. If I just did infinite solutions, this one's probably going to be
7.
Did you say 7? Gustavo?
So the first one is a same line, right?
Yes, this is if we had on the left side was a linear equation, on the right side. Gustavo, come on. You asked me a question. Okay. On the left side, if it was a line, and on the right side it was a line, they would overlap each other exactly. So they could be called this same line, or you could say they overlap an infinite number of places. Since we just did an infinite solution one, the next one is going to be?
No solution.
No solution. Do you guys know the difference? The other one we can't have a solution? Yeah, great point. Yeah?
Parallel lines.
There'll be parallel lines. What will the math look like though? Like what? Okay, let's try it. Distribute. 9x minus 3 equals 9x plus 7. Subtract 9x on both sides. We end up with negative 3 equals 7. Does negative 3 ever equal 7? Double nope. This is a number equals a number, but they are not the same number. I'm going to write over here same. This is no solution. So you have a great number of things here. Like Michael said, these are parallel lines. You can imagine they've got the same slope, that 9, but one has a y-intercept of 7, one has a y-intercept of negative 3. So they never touch. Or if you just want to look at it from a pure algebra standpoint, if you wipe out the variables and you end up with two numbers that don't equal each other, it's no solution. Are we all good on this? Gorgeous. Next. These problems, two more. These problems are not as hard as you think they are. I promise they're not. But it feels confusing because there's more than one variable here. This is going to be used a lot in calculus, if you go on to calculus, where you have to, or any kind of science, if you're actually going into a science field, you'll use this skill a lot, which is solving a variable for another variable. And if you're not going into a science field, if you're taking like physics or chemistry or something like that, you'll use this a lot. So do you see right now that I couldn't solve for x and get a number? Why? Because there's a b and there's an a. And I don't know what those are, and I can't just solve it and get something. So instead what we're going to do is we're going to solve for x, but it's going to look like x equals a big equation on the right side. And that's the correct answer. We're just solving for a variable and moving everything else over. All right, so talk to me. What should we do first? Distribute. 6x minus 5a plus 4b equals 4x minus 2. Ooh, go get a prize right now. Go on, Alondra. Very nice. I like the nod that you gave me, too, when you were like, you mean 15? And I looked at you and you're like, that's right. And I'm like, oof, yikes. Okay, all right, next up. We're trying to get x by itself. Yeah, Philip?
I would go minus 6x.
Okay, so you're putting the x's over here.
Yeah.
That works. Negative 15a plus 4b stays on the left, and on the right side I've got negative 2x minus 2. Okay, we're going to go with Philip's method here where we're getting everything on the right. We're getting x on the right and everything else on the left. What else do we need to move away from the x? Plus 2. How come I'm not combining that with anything else over here? Right, they have variables, so I can't. Now what? So now I end up with what? 15 divided by 2, 7.5a minus 2b minus 1 equals x. And this is correct. This is the answer. It doesn't feel like an answer. It looks messy and gross. But you use this skill a lot in science classes and in real life science and in calculus. We okay? Nope. Last one. A minus P equals P R T. This time we're going to solve for P, and I'm going to show you a cool trick. What do you think we should do first? Add A? Well, A is already... Yeah, let's add P. So A equals positive P plus PRT. Do you see the problem right now? You can't put these together, right? Because one has an RT and one doesn't. Does anybody have a brilliant idea of how we could get that P away from that stuff? P squared? No, we can't multiply by a P, yeah?
Can you divide by P?
Sure. Are you saying like factor it out? You're saying no solution. Do you see how if I divide or factor out the P, then I can divide out that 1 plus RT and just leave yourself with P? So one way to do it if you're stuck in a situation like this is to factor out the thing that you want to take out. Is this something you've ever done before? It's like backwards distribution, like factoring. What can I take out of both of them? If I take something out, I only put one of them out front. It's hard when it's letters, isn't it? So my divide by 1 plus RT. So my answer ends up being A divided by 1 plus RT equals P. That's a math trick. Ryan, you should get a prize for that. All right, I'm going to give you the remaining 50 minutes to get this assignment done in class. Page 92, numbers 18 through 36 evens, 41 through 45, and 50 through 56 evens. Like usual, I'm going to put the book up here so that you can take pictures and use it. And then I've got 3 people who need to be finishing a test with me, please.